periodic table. Due to the discovery and isolation of large number of elements, there arises a need to classify these elements in a systematic manner, in such a way that all those elements which have similarity lies in a particular family. For that, there was a need for a systematic arrangement which was in the form of a periodic table. In your lower standard, you must have learned about the systematic arrangement or the discovery done by various scientists such as Mendeleev, Doberanus, Newland, etc. In this topic, we are going to deal with modern periodic table given to us by Moseley, which we also call it as modern periodic table or new form of periodic table or long form of periodic table. This periodic table is very useful to us in the sense that the arrangement of elements tells us the relation of an element with other members of the family, or also about the physical and chemical properties, which are very useful to us. So let us study in detail the modern periodic table given by Moseley. Modern periodic table is the modified form of Mendeleev periodic table. Moseley stated that atomic number is the basis of arrangement of the element rather than atomic weight, which was given by Mendeleev. Now his modern periodic table has certain special features, or which we call it as salient features. Let's see what are the salient features of the modern periodic table. Moseley's modern periodic table was classified according to the arrangement in the increasing order of atomic number and not atomic weight. His periodic table has 7 horizontal rows called as periods and 18 vertical columns called as groups. Now each 18 vertical columns accommodates element with the same outer electronic configurations, hence having similar properties. 18 vertical columns consist of group 1 to 17 and 18, which is called 0 group. Group 1 and 2 and 13 to 17, 1A to 7A are called normal elements, whereas group 3 to 12, that includes 1B to 7B and 8, are known as transition elements, whereas group 18, 0 at the extreme of the periodic table was known as noble or inert gases because the outermost shell, that is orbits, were completely filled. As a result, they do not take part in any chemical reaction. Reactive metals are in group 1A and 2A, which are called as alkali metals and alkaline earth metals. Whereas if you see the periodic table, that is modern periodic table, there is a gradual arrangement of the elements and the properties of some of the elements reappear after a small interval of time. These properties we call it as periodic property. As a result, Moseley stated the property of an element is the periodic function of its atomic number and not atomic weight. Now let us study about the periods given by Moseley's modern periodic table. In Moseley's modern periodic table, there were 7 horizontal rows, which we call it as periods. The first period is known as the shortest period, consisting of only 2 elements, beginning with hydrogen having atomic number 1 and ends with helium, an inert gas completely filled. Second period is called as the short period, which consists of 8 elements. To begin with it starts with lithium having atomic number 3 and ends with neon with atomic number 10. The third period is also known as short period, again consisting of only 8 elements. To begin with it starts with sodium and ends with argon having atomic number 18. The fourth period is known as long period, consisting of 18 elements. It begins with potassium having atomic number 19 and ends with krypton having atomic number 36. The fifth period is also known as long period, consisting of 18 elements. It begins with rubidium having atomic number 37 and ends with xenon with atomic number 54. The sixth period is called as the longest period, consisting of 32 elements. It begins with cesium, atomic number 55, and ends with radon, having atomic number 86. Whereas the seventh period is called incomplete period, starting with francium, having atomic number 87. Now, out of all these periods, the important period for you people are only the first, second, and third period. Second period, which consists of 8 elements, starting with lithium. The other members of the period are lithium with atomic number 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, and neon 10. Whereas third period, short period, consisting of 8 elements, starting with sodium 11, magnesium 12, aluminium 13, silicon 14, 15 is for phosphorus, 16 for sulfur, 17 for chlorine, 18 for argon. The second period is known as bridge element because it shows a diagonal relationship between second period and third period. For example, lithium resembles some of its properties with magnesium of period 3. Similar manner, beryllium with aluminium, boron with silicon. So, second period elements are called bridge elements and the third periods are called typical elements. Now let us see some trends of properties across the period. The number of shells in a period remains same, but the atomic number goes on increasing by 1. That is, 1 electrons get added to the outermost shell. Let's see some of the trends now. To begin with it, let's take period 2, which consists of lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. The atomic number starts from 3, 4, 5, 6, 7, 8, 9 and 10. So the electronic configuration will be, for lithium it is 2, 1, beryllium 2, 2, and in case of boron it is 2, 3, then carbon 2, 4, nitrogen 2, 5, oxygen 2, 6, fluorine 2, 7 and neon 2, 8. Lithium is a metal, beryllium again a metal, whereas boron a metalloid, whereas carbon non-metal, nitrogen non-metal, oxygen again non-metal, fluorine again a non-metal, and neon is a noble gas. Reason? The entire orbits of neon, the whole orbit, are completely filled. Now we come to the valency part of it. Lithium has 1 valency, whereas beryllium 2, similar manner boron 3, carbon 4, nitrogen 3, oxygen 2, fluorine 1, and inert gases 0 valency. Now let's take period number 3. Period number 3 starts with sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. To begin with it, atomic number of sodium is 11, magnesium 12, aluminium 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17 and argon 18. The electronic configuration will be 281, 282, 283, 284, 285, 286, 287 and 288. The state of sodium will be, it is in a metallic form, magnesium again a metal, aluminium is a metal, but aluminium is amphoteric in nature, whereas silicon is a metalloid, phosphorus non-metal, sulfur again a non-metal, chlorine again a non-metal, and argon inert gas. So what do you notice? Each period begins with an element having 1 electron in the outermost shell and always ends with an inert gas, completely filled orbitals. Now, the valency of sodium is 1, magnesium 2, aluminium 3, silicon 4, phosphorus 3, sulfur 2, chlorine 1 and inert gas argon 0. If you see with respect to chloride, sodium will form sodium chloride, magnesium chloride, that is MgCl2, aluminium will form AlCl3, silicon will form SiCl4, phosphorus will form 2 of them, PCl3 and PCl5, whereas sulfur will form S2Cl2. Chlorine and argon, they will not form chlorides. In case of bonding with respect to NaCl, that is sodium chloride, you will have ionic bonding. It is between metal and non-metal, so there will be an ionic bond. Whereas in case of MgCl2, again an ionic bond. AlCl3, both ionic as well as covalent. Whereas SiCl4, that is silicon tetrachloride, it forms a covalent bond. PCl3 and PCl5, they form again a covalent bond. And H2Cl2, it's again a covalent bond. Now to talk about their oxides, sodium will form Na2O, sodium oxide, MgO for magnesium, Al2O3 for aluminium, SiO2 for silicon, P2O5 for phosphorus, SO2 and SO3 both for sulfur, whereas for chlorine it will be Cl2O7. Again the bonding will be Na2O electrovalent bond, that is ionic bond, because it's a metal and a non-metal. MgO again electrovalent, Al2O3 again an electrovalent, whereas SiO2, P2O5, SO2, SO3, Cl2O7, all of them will form a covalent bond. Now to see the basic nature, Na2O is a very strong base followed by MgO. Aluminum oxide is amphoteric. So as you go across the period from left to right, the basic character decreases and acidic character will increase. The most powerful acidic nature will be exhibited by Cl2O7. Now let's see some of the trends. If you go across the period, the electropositivity will go on decreasing. What is electropositivity? The tendency to donate electron. Whereas the electronegativity will go on increasing as we go across the period from left to right. So if you see the hydride of a metal in case of third period, sodium hydride, strong base, magnesium hydride, weak base, compared to aluminum hydride, which is a very weak base. Whereas silicon hydride is again a very weak base, phosphorus hydride again a weak base, and hydrogen sulfide weakest, and HCl strongest acid. So the acidic nature increases, basic nature goes on decreasing across the period from left to right. So now student, let's see the properties with respect to groups. We have already seen it with respect to period. Now you already know it. In modern periodic table, how many groups are there? Total 18 groups. These groups are divided into various elements and families. Let's begin with it. To start with, group 1, which is also called 1A. It consists of alkali metals having 1 electrons in the outermost shell. Second group is called alkaline earth metals having 2 electrons in the outermost shell. 3 to 12 is called as transition elements having variable valencies. That includes 1B, 2, 7B and 8th group. Whereas 13 to 16 are called post-transition elements. The 17th group, that is also known as 7A, is halogen having 7 electrons in the outermost shell. Whereas 18th group is called noble gases, that is inert gases having completely filled octet, that is 8 electrons in the outermost shell except helium, which has 2 electrons, that is duplates. Now transition metal are placed between the strong electropositive on the left hand side and the most powerful electronegative element on the right hand side. So transition metals lies between these two, whereas inner transition elements are placed at the bottom of the periodic table in 2 separate columns. They are known as lanthanide series or actinide series, and noble gases at the extreme right of the periodic table, since they do not take part in any chemical reactions.